So let's examine the following example in which we're going to deal with electric circuits and capacitors. Suppose a capacitor with a capacitance of 2 microfarads is initially charged using a 12-volt battery. So that is described in the following diagram. So we have our 12-volt battery that essentially charges our plate as shown in the following region. So this plate gains a negative Q charge and this plate gains a positive Q charge. Now, the battery is then removed from the circuit and a second capacitor is placed into that circuit in the same location as shown in this diagram. So, at the instant the battery is replaced with our capacitor, these two plates of our capacitor are neutral. They have no charge. And these plates are charged with the same exact charges given by positive uppercase Q and negative uppercase Q. Now, as a result of the voltage that exists between these plates, that means electrons will begin to flow from the lower potential to the higher potential, from this plate to this plate. So electrons in this section will tend to flow in this direction. Now, when the electrons flow onto this plate will gain a negative charge. Now, those same electrons cannot actually jump onto this plate, but what happens is the electric charge that is collected on this pushes these electrons away, and these electrons flow onto this plate, the higher potential plate. So, what takes place? Our electrons flow from the lower potential plate to our higher potential plate. Now, eventually this will gain a negative charge, this will lose a charge, so this will become positively charged, while this will still be positively charged, but it will have a slightly less positive charge because it gained some electrons. So there will basically be a redistribution of electric charge after some quantity of time has elapsed. So let's suppose the new charge on these two plates are given by positive Q1 and negative Q1, so they're equal and opposite, and the charges on these two plates that have accumulated are equal to negative Q2 and positive Q2. Now, once the second capacitor is fully charged, the voltage across these two capacitors is equal to 2 volts. And at that point, we want to calculate the capacitance of our second capacitor. So, how exactly are we going to go about calculating this capacitance of the second capacitor? Now, we have to use a trick. So we essentially have to recall that in these cases, electric charge is conserved. So notice in this case, the total electric charge on the entire circuit was 0. Positive Q minus Q gives us 0. Likewise, we had a net charge of 0. Positive Q minus Q. Now, this case is no different. If we add these guys up, we get a net charge of 0. So it's completely neutral. So, now, let's only examine the left side of our electric circuit. So beginning from here, the left side, and by left side we mean this side, has a positive Q charge. This side has a positive Q charge, and this side should also have a positive Q charge. So positive Q is equal to Q1 plus Q2. The charge before is equal to the charge after. So positive Q is equal to positive Q1 plus positive Q2, which is given by the following equation. Now, of course, we can also look at the right side. Negative Q is equal to negative Q, which is equal to negative Q1 plus negative Q2. Now, we're going to only look at the left side. And this is the equation that we get as a result of the conservation of electric charge. And we're going to use this to solve for our C2, the capacitance of this second capacitor. So let's suppose the capacitance here is given by C1, the capacitance here is given by C2. Now, the voltage here, well, the voltage here is 2 volts, and let's call the voltage here V nu, and the voltage here is also V nu. So we're going to use this in just a moment. Now recall the Q, the quantity of charge on the plate, is equal to the product of the capacitance of that plate and the voltage across that plate. Now, we essentially use this equation and rewrite this equation. So Q becomes C multiplied by V, Q1 becomes C1 multiplied by V nu, and Q2 becomes C2 multiplied by V nu. So V nu is simply the voltage across our two plates after this capacitor is charged. So that is given by 2 volts. So V nu appears on this term and this term. We can take them out as shown. So now we bring the V nu to this side and we bring our C1 to that side. So we see that our capacitance of the second capacitor C2 is equal to C multiplied by V divided by V nu minus C1. Now C and C1 have the same exact quantity. So this capacitor has not changed. These capacitors are the same capacitors with the same capacitance. So C is equal to C1, which is equal to 2 microfarads. Now V nu is given by 2 volts and V is simply our 12 voltage battery. So we see that 2 microfarads multiplied by 12 volts divided by 2 volts minus 2 microfarads gives us 12 microfarads. So we saw by using the conservation of electric charge that the capacitance of the second capacitor is given by 12 microfarads.